Okay, we're going to look at angles between intersecting lines. So we've got some graphs here of lines, and we want to find the angle between them. If you take a look, there's really more than, so angle theta is the angle between the two blue lines, but we could also get this angle here by subtracting from 180. So oftentimes if you're asked for the angle, they might say find the acute angle between two lines. If they don't, then you could give either answer. So taking a look at this, what we've written down here for theta, it's equal to the absolute value of theta 1 minus theta 2. Remember, these absolute value, we haven't spent a lot of time on it, but really absolute value signs make a negative number positive. So that's basically saying, in this case, this is bigger than this one, so you will have a positive, right? But say you switch them around and you put this as your theta 1, a smaller minus a bigger, then you get a negative answer. If you take the absolute value, make it positive, it will be the same as this. Okay, so just like, so if you, for example, have 10 degrees minus 8 degrees, the difference is 2 degrees. If you put 8 degrees first, you get negative 2. So now if we put absolute values for that, we get positive 2. Okay, it's not actually changing the digits. So now how do we get those angles? Well, want to form triangles, right? These aren't angles in standard position. These are lines here, right? So you want to, maybe I'll change to red, draw some triangles to get the slope, to get the, well, actually it ends up being the slope, but some sides of the triangle. So look for nice, so that's a nice point, for example, and so is this. So if I draw this triangle, kind of like that, then for theta 1, so there, this is 2 units and this is 6. So tan of theta 1 equals 6 over 2, which is equal to 3. So theta 1 equals tan inverse of 3. Okay, we can calculate that in a sec. And then if you look at this other line, that's a good point, an x-intercept. This looks like a good point. Okay, so that's 2 and that's 4. So tan of theta 2 is 2 over 4, which reduces to 1/2. So theta 2 is tan inverse of 1/2. Okay, so get out your calculator, make sure it's in degree mode, and then go second tan of 3. Okay, 71.565. And then second tan of 1/2, 26.565. Okay, so the difference between them. Okay, remember, so absolute value 71.565. Really, we don't need the absolute value. Because that's bigger anyway. You could do this all in one step in your calculator, both of these, or you can go, okay, go back, copy that out if you have the ability in your calculator. That's why I recorded a few decimal places in case you didn't. And that is 45 degrees. Okay. And that's all you do. Okay, so sometimes you might not be given an actual graph, but the first couple here you are. So here's another one. Okay, so again, draw some triangles. So I'm going to look at the steeper one here and look for, okay, there, down. All right, so that's 4 and 2. And then this one, I'm going to go here, and that's 2 and 4. Okay, so I'm going to do it all in one step here. So theta, which is this angle here, is going to be equal to, I'll take the larger one first. So tan inverse of 4 over 2. Okay, you can reduce it. Obviously that's 2, but your calculator doesn't care. So if you don't worry about it. Tan inverse of 2 over 4. Again, you could reduce that to 1/2. So now in your calculator, you could do this all together. Even the absolute value, but I'm just going to do the inside part first. So second tan 4 divided by 2, or you can do that in your head, minus second tan 2 divided by 4, or reduce it to 1/2. Okay, and then it is already positive. If you weren't sure, then where's the absolute value is located in math, okay, in cursor to the right to num, and ABS stands for absolute value, and those are those symbols, and then you could copy out that answer and you'll get the same thing. Okay, so 36.9. It didn't say what to round to, but let's go to the nearest tenth. Okay. All right. Direction of the slope. Sorry, I think there was something up here. Location of the intersection is irrelevant. So that's what we were trying to show you here. The first one was intersecting on the x-axis. This one was not. So we just always go horizontal from there if we're looking at creating some triangles, right? We have to have a common reference point in that sense, okay? Okay, so when we're looking at this one, there's a note here, the direction of the slope is irrelevant. This is going sort of below the horizontal here. But when we deal with our angles, or calculating them, we're going to end up here getting a negative angle, okay, if we look at the actual direction. So what you want to think of is really think about the slope as opposed to maybe making those triangles. That's how you get the slope. But this will have a negative slope, right? So go back to my red here. All right, so what is the slope of this? So there's a triangle right there. So it's 2 over 1, which is 2. All right, so our theta is going to be inverse tan, and we're going to go 2 over 1, which is 2. And then here, choose a nice, that one. So that's going to be negative 1 over 2. So that's going to be tan inverse of negative 1 over 2. Okay, so we're actually, if you form the triangle and think about this angle with positives, then you would add those two together. But if you want to keep using the same formula, then do it, okay? But think about these as slopes. So a little bit of an extension from the last two that we did, okay? So in your calculator, you go second tan of 2 minus second tan of negative 1/2, and you get 90. And may not look quite to be 90, but take a look. These aren't perfectly square grid markings, so it's pretty darn close. Okay, so yes, you can do the two angles and add them together. You would keep that as a positive, but this formula will always work if you think about these ratios here as the slopes, right? Tan is opposite over adjacent, and opposite is always your rise, and adjacent's always your run. Okay, so that's how it works. So now we've just learned we can use the slope to help us find the angle between the lines. We don't have to necessarily graph it and form triangles and that kind of thing. So, you might want to do a sketch here. So this would be something like, I don't know, that would be 4x minus y equals 4x minus 5. This would be the other line. So we were trying to find this angle in here. So this is your, call that slope 1. This is slope 2. So your theta is going to be tan inverse of 4 minus tan inverse of 2/3. Okay, so now second tan of 4 minus second tan of 2/3. Okay, and it's already positive, so 42.3 degrees. Okay, kind of looks like that even from my rough sketch. Next one, determine the angle of intersection to the nearest hundredth between these lines. So notice these are in general form. So this is good practice from coordinate geometry. So I'm going to call this equation 1 and this equation 2. So for equation 1, oops, we want to, I'm going to bring the 5y over to the right and then divide by 5. So what am I going to get? I'm going to get y equals 4/5 x minus 2. So that's going to be my slope 1. Then my second equation is, I'm going to bring the 6y to the right to make it positive. So 2x minus 1 equals 6y. And divide by 6. So I get y equals 6 reduces to 1/3. Okay, so that's my slope 2. So now my theta is I'll go inverse tan of 4/5 minus inverse tan of 1/3. And we'll get our calculator. So get our calculator out. Second tan of 4/5 minus second tan of 1/3. 20.2 degrees. Okay. And next one, angle of intersection. So these have already been put in slope y intercept form. So take a look at them though. That slope there and that slope there. What do you notice? This is -3/2. This is +2/3. These are already negative reciprocals. So you already know they meet at 90 degrees. Okay, you can calculate it if you want, but it's going to give you the same answer, right? So -3/2 minus tan inverse of 2/3. And let's just check. So second tan of -3 divided by 2 minus second tan of 2 divided by 3 is -90. Absolute value is +90. There you go. Okay. And then determine the angle of intersection between these two. So again here, solve for y. So that's going to be -3/2 if you reduce that. Okay, so they have already, you see, they have the same slopes. Okay, so therefore they are parallel. All right, now are they parallel in exactly the same line? Are they parallel in what we call distinct, separate? So coincident or distinct. Well, if they are distinct, then this would be different from this, which it is. So these are what we call parallel and distinct. Distinct as y-intercepts are, different. Okay, now if we try to find the angle in between, what happens? Tan of, well, you're doing the same thing, right? So you end up getting, so tan inverse of -3/2 minus tan inverse of -3/2. You're subtracting things that are equal to each other. So you get 0 degrees. Okay? And that's it.